Okay, so this is day 2 of the quadratic formula word problems, which is actually day 4 of applications in just quadratic equations. We have the quadratic formula now, but that doesn't mean that we have to use it for these. As we've talked about, you could solve these by factoring as well. That would be absolutely fine. So this one, we've seen an example like this before. It's just got a couple of little quirks to it. So let's get started. We're looking for two integers, right? It says the sum of the square of two integers, and it gives us a lot of properties of these integers, but we'll talk about that in a minute. So what I need to know is that I have two integers, so let x represent one integer. And in this is one of those cases that this question is very simple, and so we may not need two variables, but there's no reason why you can't. So we could let y represent the other. Now, what do we know about these integers? Well, they are consecutive, but they're positive and they're even. So the positive part we don't have to worry about till later. The fact that they're consecutive even integers, that is relevant. If you remember in the last question, and some people get tripped up by this, consecutive integers would be x and x plus 1. But if they're both even, then I'm going to have x as one of my integers, and my other integer, which I called y, will be x plus 2. So if my first integer was 2, so that's an even, the next one would be 4, I'd add 2. The next one would be 6, add 2. The next one would be 8, add 2. That's true for odd as well. Some people think you add 1 because 1 is an odd number, or add 3 because 3 is an odd number. But if you start on an odd number, to get to the next consecutive one, you would still add 2. Okay, so I've got x and I've got y, which is x plus 2. Next part, the square of the sum of those two consecutive even integers is 3,364. So what is the square of the sum? So first I'm going to sum them. That's x plus 2. So here's my first one, and here's the next even integer. And so this altogether is the sum of those, but what I actually want is the square of the sum. So this whole thing is the square of the sum of two consecutive even integers. That is something that you need to understand and be able to sort of figure out on your own and manage on your own, because every one of these questions is different. We've talked about this before. It could be the product of two integers. It could be the sum of the squares, or the square of the sum, or the quotient even. Probably not, but all of those things are statements that you should be able to understand and turn from English language into math language. And now I can just go ahead and solve this. And there is an actual really easy way to solve this question, but we'll do it the long way in case you didn't notice it. So this would be 2x plus 2 all squared equals 3,364. And at this point, as I could take the square root of both sides, that would be the easy way, assuming that 3,364 is a perfect square, and it is. But if you didn't notice that, you'd expand. So this would give you 4x squared plus 8x plus 4 minus 3,364 equals 0. And I would then get 4x squared plus 8x minus 3,360. Oops. Equals 0. And I'm pretty sure that I'm going to be able to common factor a 4 out of all of that. So divide both sides by 4, pull a 4 out of every one of those terms, and I get x squared plus 2x minus 840. So now it is equal to 0. So now I'm looking for two numbers that have a difference of 2 and multiply to 840. And that is really not too difficult to find. Again, because the difference of 2, so I just have to get into the ballpark and then try a few numbers and figure it out. And, I already know that I don't need the quadratic formula here. It's going to be factorable. They're integers, so it's got to be integer answers, so it's going to be factorable. The easiest way to do this is take the square. This is a little bit strange, but see if you can follow me. Take the square root of 840. And that's going to get me in the ballpark because that number times itself is 840. So two numbers that differ by 2 will be close to that. So I'm going to kind of try a number above and a number below. The answer I got when I took the square root was 28.9, almost 29. So I kind of went down one and up one, and I got 28 and 30, and I multiplied those together, and that is 840. So this is going to be x plus 30 and x minus 28 equals 0. And as always, check that, make sure that it's correct. X equals negative 30. X equals positive 28. And here's where I got to go back, and you always have to interpret your answer. This one's not about lengths. It's not about number of students, not about people or cookies or anything like that. It's just integers, but it says right in the question that they have to be positive. So just because of that, I know that this one is inadmissible. Which means my answer is 28, and the next consecutive even integer, which is 30. I kind of knew that because of the negative 30 and everything, but it's not negative 30, it's positive 30. This is the kind where you don't have to show your work. If it was one of the ones where you would, I mean, I do have my little formula here. X plus 2, which is 28, plus 2, which is 30. Therefore, the two integers are 28 and 30. Okay, so pretty straightforward, but a couple of little things to think about if they're even integers or odd integers, consecutive integers. Sometimes you have 3 consecutive integers. Like there are certainly different kinds of questions where they just twist things around a tiny little bit, right? And this one was the square of the sum, different from the sum of the squares that we had done previously. But that one was fairly similar to ones we've done in the past. This one is a little bit different. Ned throws a football to Ted. The path of the football is modeled by this equation that's given here. It's important to note that when you're given the equation, it is different from all the other kinds that we've done so far where you're not given an equation and you have to develop it. So in some ways, these ones are a little bit easier, but there is one thing that you should know when you're given the equation. Very, very often, it boils down to doing a little sketch of this situation and thinking about the important properties of the graph. So back 2 units ago when we did a lot of graphing quadratics, that's going to really come into play for these kinds of questions. So I could complete the square and I could find some details about this in order to graph it, but I already kind of know what this is going to look like. If I think about in real life what would happen, let's see. So this is distance. It says how far does a football travel, so I know that this distance, it should say here what H and D represent. It doesn't, but normally it would. And this is height, okay? So he throws the football. It starts up here in his hand somewhere. We don't yet know what that value is, but we will in a moment. And the football goes up and hits a maximum height and then drops down. I'm just going to try that one more time and stop when it gets here. And then it would continue. The parabola continues both ways. But in the real world, it only exists when time starts at time 0 until it hits the ground. Then the ball wouldn't go down into the negatives. It would start bouncing around. So this model is actually only true in the real world between those times, right? So it's an interesting thing to think about. But the mathematics would go on in both directions forever, right? But that's our job, part of our job to interpret that. What was the initial height of the football? So where does that occur? This is where you start thinking about the graph and thinking about what that is asking. That occurs here, where time equals 0. Not time, sorry, distance. This isn't a time one. So where the initial distance is equal to 0. So where d equals 0, it hasn't gone anywhere yet. That's the initial height. Okay, turns out that's like the y-intercept or the h-intercept, the vertical intercept. And so I'm just calculating that. We know how to calculate intercepts as well, so there's lots of different ways to think about this. This is, again, going way back several units ago where we talked about finding intercepts and that sort of thing. And so if I sub that in, so find h. So I get h equals negative 0.02 times 0 squared plus 0.94 times 0 plus 2.36. And what we notice is this is going to be times 0, so it's gone. This is times 0, so it's gone. And when you've got standard form, the only thing that standard form is good for, aside from the fact that it's fully simplified, and we like that mathematically, the only thing that it's good for is it does give me the y-intercept or the vertical intercept very quickly. Still should be showing these steps of subbing in 0, but there it is. Okay, so therefore the initial height was, it doesn't even say what meters or feet or anything like that, so I would say 2.36 is probably not feet, it's probably meters, right? Because that would be maybe a tall person where their hand would be if they were letting go of a football. Okay, so that's that one. So I realized we were finding the vertical intercept. I subbed in d equals 0 into the equation that was given to find that. How far does the football travel before hitting the ground? Well, where does that occur? Look, my graph tells me where that occurs, and now when I think about what property that is, that's one of the x-intercepts, or the horizontal intercepts. Where do they occur? They occur when h equals 0. So in this case, I'm going to find d when h equals 0. This is another skill that we have. Sub that into the equation, and I get 0 equals negative 0.02 d squared plus 0.94 d plus 2.36. So there are a couple of ways that you could do this. You could try common factoring out. Might seem a little bit weird, but common factoring out the 0.02 that's out front. See what you get, and you may end up getting something that works out kind of nicely. I don't know. Or you could just plug this into the quadratic formula. Again, that's often something that you're going to do when you have these real-world applications. It's not going to give you good answers. Just to show mathematically what it would be like, I'm going to go ahead and factor that out. So 0.94, I'm just using my calculator for this. 0.94 divided by negative 0.2 gives me negative 47d, and 2.36 divided by 0.2 gives me negative 118. So two numbers that have a difference of 47 and a product of 118. I'm wondering if that's going to work. And I don't think it does. I still don't think that's factorable. I can divide both sides by the negative 0.02 and get rid of that. So even though it turns out that is not going to work to be factorable, I still have easier answers to work with. So I don't know. It's up to each person to decide what's worth their time. Some people like doing it one way, some people like working with integers, and some people don't. Some of you might want to go back and try plugging those guys into the quadratic formula. Keep saying that all day today. It is the quadratic formula. Into the quadratic formula, you might sub that in and see if you get the same answer. You should, if you've done it correctly. Might be something worthwhile trying. So negative b, which is, so I'll write this down. Negative b plus or minus the square root of b squared minus 4ac all over 2a, which is positive 47. So two negatives makes a positive. And then in brackets, negative 47 squared minus 4 times 1 times negative 118. All over 2 times 1. Which equals 47 plus minus, I'm just going to use my calculator for this part, so 47 squared plus 4 times 118, which is 2681, and that's like not a perfect square, so that's how I know that this isn't factorable. And so I get d equals 47 plus the square root of 2681 over 2, or d equals 47 minus the square root of 2681 over 2. And let's try these guys. I got 49.39, and minus is negative 2.39. Now think about these questions, and I'm going to go back up to my diagram. My diagram's not drawn to scale, but when you really get this stuff, you can draw them to scale enough where when I look at it, I mean, just take a look, right? That's going to be close to 0. So that's the negative, approximately negative 2.3. And this one's going to be far down. That makes sense that it would be way down there. He's thrown the ball very far. So that one's going to be the positive, what was it? 49. So he threw it almost 50. We're calling this, I guess, height's probably in meters as well. Maybe it's in feet or something, but or yards. But that's a big throw, 50 meters, almost 50 meters, right? So this one, it is a length or a distance, so inadmissible. And therefore, the ball hits the ground after 49.4 meters. That's rounded to 1 decimal place. Okay, you should have a handout now, and you can go ahead and do those questions from the handout.